Welcome to the Startup Leaders Show, where we learn lessons from startup founders and executives. I am your host, Lisa Dreher, and I'm really excited to introduce our guest for today, Rick Ward. He is the CTO of OrbitsEdge. Welcome to the show, Rick.
Hey, it's nice to be here with you again.
Absolutely. Thank you so much for making time to be here. And I know we've had you on the show a couple of times, but it's been a while. And I'd love for you to start by giving us an update on what's happening with Orbit's Edge, and then maybe just a little bit of background on yourself.
So, OrbitsEdge has been pretty busy, and some of it, honestly, is a bit back to the roots. When we were first started, the idea was to create an environment that would allow autonomy to operate in space. So, the idea was really behind space mining. So mining robots would require, well, mining would require robots, and robots require autonomy. And the current computers did not provide that. So fast forward to today, and what we would have called autonomy back then is now being called AI. So we're actually kind of shifting back our emphasis to have a significant AI component to facilitate not necessarily robotic mining yet, but back to what I'd call complex operations, things like refueling and proximity operations, repair, assembly, things like that. So we're looking at not only providing the hardware that can facilitate those operations, but also developing some AI agents to allow that to give kind of a full stack service for customers.
Wow, that sounds fascinating. I can't wait to dig into that a little bit more. And give us a little background on yourself, just so we have that as a point of reference.
Yeah, so my first space job was Deep Space Industries, and that was a space mining company, and it was a awesome place to get an entry into the space industry. The alumni from that company have ended up just about everywhere. They do really cool stuff despite being such a small cohort, and it really got me thinking about what sort of next level space architecture was possible and what infrastructure is necessary to facilitate that sort of those sort of more complex missions. And yeah, that's pretty much the genesis of OrbitsEdge and me in the space industry.
Great. So maybe we can step back a little bit, because I know Orbit's Edge was really focused on getting that sort of data center hardware out into space on orbit and operating. So can you talk a little bit about what is required to really operate a space-based data center?
Um, so if you look at it like a lot of things, you can do it kind of in stages. We're looking at primarily space compute for space data. So just us going in competition with AWS or something like that is not not the immediate step. In fact, we have a good relationship with AWS, so that's relatively unlikely anyway. But what we're honestly looking at is how to get from very little modern current compute in space to that becoming the norm. And the way we're looking at it is by stages. We're looking at our first product as being something like this. This is a 2U compute module. It has this is a mock-up, but it has radiation shielding and thermal management, so that COTS compute hardware, single board computers, can operate in space environments. From there, we're calling this the Edge 10 because it's 10 watts. It's also 2U and about 2.5 kilos is what we're coming at right now. So I'm just going to call it 3 kilos. We're looking at that. Following Edge 10, we're looking at Edge 100, which is a little bit larger, but 100 watts. So we're talking about a lot denser compute at that point. Followed by Edge 1000, which is getting into either really crazy powerful GPUs or more conventional computers. like servers, micro data servers.
Mhm.
And from there, we'd really have to scale to larger form factors. As you get bigger, it not only gets more expensive for you to develop, it also gets more expensive for you to launch.
Mhm.
Your total addressable market shrinks. So there's a lot of reasons that we're encouraged to do smaller form factors first. And among them, we'd have to do the small stuff anyway as a prototyping plan. But this way, we get to make money off of the prototypes and turn them into product lines instead of building like three.
Yeah.
You're always going to get more data if you can build hundreds or thousands of something than if you build single digits. So we feel like that's kind of the best way to leverage to get to orbital data centers. Now, long run, and I'm talking decades, um, our total energy consumption globally for data is exceeding like 1% of total global energy consumption. That number is going to increase as more of the population, more of the planet gets into a data centric world. And it's also going to increase for the part that's already in a data centric world because we're generating more and more and more data, and we're finally figuring out what we can do with some of that data. That's been we've been stockpiling all these libraries of stuff, not knowing exactly what we were going to do with it for the longest time, and
Right.
now we're finally getting to where we can do something with it. So our data demands are not going to go down anytime soon. And at some point, we do expect that we'll have something that you could call a space cloud, because Edge 10, that's local. That is purely an edge play. Edge 1000, now you're getting into like petabytes of storage per unit, and you're getting into a place where you can conceivably handle your data plus somebody else's data. Once you get beyond that, then you're getting into free flying satellites dedicated to data processing and storage and nothing else. At that point, you're like, yeah, that's kind of a space cloud.
Yeah.
Um, when you get there, for a good while, that will be space cloud for space data. But there's conceivably a point where various of the sociological and energy constraints are pushing against more terrestrial storage of data.
Mhm.
There's also some questions of like data sovereignty. There's also the aspect of I hate to say this one, data security, because even if nobody can physically walk up to your server, that doesn't mean it's secure. I mean,
Mhm.
it's kind of the opposite of that from a space standpoint. But that is one vector that you can kind of rule out. So there's an element to it. Another element might be land use. It could be that you know a server like on Manhattan Island is an opportunity cost that you don't necessarily want to incur. That land could be better utilized doing something else. Plus, who knows what the energy crunch on the infrastructure is going to be like at this point, because we are talking multiple decades in the future.
Sure. Sure.
And that can push you to putting some of your most expensive data in the most expensive place, which will be space. But it's also, from a terrestrial standpoint, it's a zero infrastructure play. All you need is a pipe at the bottom, pipe at the bottom, and a pipe at the top, and you'll be fine. So, are we going to get to? I heard somebody say zettabytes recently. Eventually, sure, yeah. That's not a today thing. Like that's a little ways down the road.
Right, right, right. So this actually brings up a question for you, which is it seems like there's also potentially an environmental impact as well to
Mhm.
maybe moving some of our data center resources into space. And I understand the cost. Maybe there's a point where the cost makes sense, and both, from a cost perspective and from an environmental
Yeah.
perspective.
And I'm looking at the environmental aspect as part of the cost. I'm not necessarily weighing this as purely dollars versus dollars.
Yeah.
But I am saying that all in cost, from land use, from power consumption, from uh, from end of life disposal, from all these different considerations, they will all have to weigh into it, and that's why I feel like the first place will be these high dollar density per square meter areas. And
Sure.
another aspect is, if you look at just the curve, the cost curve, a terrestrial data center is not super crazy expensive to set up. All the guts, all the computers, they're the same whether it's space or terrestrial.
Hmm.
So we can call that flat. Um, but it does have a high operating cost per day. So in terms of how much processing you get done per watt, your most efficient day is going to be on day one that you install a computer. On day 1000, A, the computer has slowed down a bit. B, there are new computers out there that are more efficient. So this computer that you installed 1000 days ago is now comparatively less efficient than the newest stuff out there.
Hmm.
So you have that kind of cost structure for terrestrial use. So you could kind of say that it's starts out flat, but then it kind of goes up because you've got
Right.
all this operating expense. Now, space, on the other hand, is the opposite. It has this ridiculously high infrastructure setup cost, and from there, your operational costs trail off, because you paid for your power. You paid for your power because you bought solar panels, but you're not connected to a grid. You don't have people walking back and forth and up and down the aisles servicing your stuff. But then again, you also can't really service your stuff. So it looks different. Um, but if we do get to a world where launch costs drop to $100 a kilo or $50 a kilo, as some of the CEOs have said is possible, or
Hmm.
have said that they plan to do, well, that changes your upfront cost structure. And you might say at X launch costs, the break even point is 10 years. Well, 10 years, the stuff is too old anyway. It doesn't matter. Uh,
Sure.
but at one half X launch cost, maybe the break even point's at like 3 or 4 years. And then
Sure.
you're like, oh, well, that kind of that's kind of appealing right there.
Yeah, well, and also I think there's a resiliency consideration as well, right? So you're not having to deal with, I mean, you're right, you have to deal with space, but at the same time, you're not having Earth types of things, storms
Yeah.
or natural disasters or, right? All of these things that can impact the operation of a data center on Earth um, don't
We,
necessarily exist in space.
we have different sorts of storms.
Yeah, true.
There's some interesting stuff going on right now with the current sunspot cycle. It is yet again defying previous expectations. That was some of the news from last week.
Yeah.
Um, so in terms of that, yeah, with our radiation shielding and thermal management solution, we actually have reason to believe that is not just pure hope and hype, that our hardware will be in better shape, um, 5 years down the road after installation, better shape than the stuff that is currently going into data centers with standard data center treatment.
Sure, sure. Well, so let's shift gears a little bit and talk a little bit about what I guess rolling in AI will mean for space-based data centers.
So AI is its own little thing. Right now, we're looking at it as two broad categories. We have edge AI and what I'd call server-based AI. Edge AI is where there is an agent that resides on a little computer that is, well, right where the stuff happens. That would be on your phone, on board a car, on an airplane, um, at a drilling well site, at a factory, all these places where the data is generated and then it moves a very short distance, is consumed, and all you send back to whoever is yeses and nos, just status updates, and every so often writing a letter home or something.
Mm-hmm.
The other kind is server based. That's where your query goes to some massive data center, and that's like Chat GPT. There are ways to do LLMs as edge devices, and in a lot of cases, they're functionally no different from the one at the server, but the server is just going to be a more powerful one. And we are primarily focused on edge AI, as you can imagine,
Yeah.
because we're not, one of the things we're wanting to do is cut the cord. We're wanting to not be super reliant on communications up and down. We want to have the freedom to operate in a communications denied environment, to be
Mm-hmm.
able to operate outside of latency constraints. There's still a person in the loop, but that person in the loop, things will still go on if you're disconnected for minutes or hours. So that's one of the important things. Now, having delineated the two differences of AI and how we're looking at using it, then I'm going to go ahead and say there's three broad categories of it. One is going to be Earth observation. This is where you're doing things with pictures. That might be change analysis, metadata generation, where you're just counting stuff and turning it into spreadsheets, looking for specific things, pattern recognition, all that sort of stuff.
Mm-hmm.
It's
Mm-hmm.
done on the ground. We'd like to do it in space because that is much more of it tightens up the edge. It tightens up the loop on edge. So you got that. That's Earth observation. The other one that's kind of tied with EO for um, how accessible it is going to be ISAM, or certain aspects of ISAM or OSAM.
Mm-hmm.
It's going to be stuff uh, like maneuvering, proximity operations, repair, assembly, disassembly, um, refueling, all those sort of operations that involve building stuff out of other stuff. And that could be one robot working on one satellite, or it could be 6 or 10 robots all working together on a satellite at the same time.
Mm-hmm.
And this could be in LEO, GEO, or cislunar or beyond. And as you see, once you increase the complexity of it, or you increase the latency, you get to a point where you just can't do that with direct control. Like,
Mm-hmm.
people on joysticks are going to, it'll be bumper cars. It'll be ugly. So just don't do that. Figure out how to let the robots do it.
Right.
And the third one is factories. It's not going to look like a car factory or anything, although it potentially can at some point, some sort of alien dreadnought satellite factory or spaceship factory or something. But there's a lot of things that we can do in space. There's a lot of really cool things involving crystallography, which is impactful for metallurgy, ceramics, optics, medicine, various biological processes. Um, it even affects photolithography, which is chip manufacturing. So there's some very interesting things that we're going to be producing in space, and all of those things are going to be data and telemetry driven. And that means they need their own little type of AI. They need their own subset of AI,
Mm-hmm.
and that's going to be autonomous lights out factory type AI. So I'm just going to call those the three broad categories. There's some overlap between all of them. But yeah, that's basically what we're looking at for AI in space.
Great.
And I'm sure
Wow.
there's others.
Yeah, a lot of sorry, a lot of really interesting use cases. So, where are you in terms of actually getting some data centers out into space? Are they already, we already have data centers out there. Um, where is Orbit's Edge in their progression?
So we're working on that. We are actually trying to get this thing finalized to where we can have it ready to fly. We've got some. We have some flight opportunities coming down the pike. All we have to do is be ready to meet them. And one of the things that we're trying for here is to have a generalized solution with this box. This box is intended to be generalized. So if you want to fly a Jetson Nano, we can do that. If you want to fly something else, like a dedicated TPU, tensor processing unit, we can do that. If you want to fly for some reason a regular CPU, we can do that. And as long as the power and data are about the same going in and out.
Got it.
So we're working on having it on hand so that we can just rock and roll with it. That's kind of what'll make this thing viable.
Excellent. Okay. Well, we're really excited to watch as Orbit's Edge continues to progress the data centers in space and integrate that AI capability in there as well.
Yeah, yeah. It's a pretty wild time to be around.
Indeed. Thank you so much for making time to be here today.
Always a pleasure.
Absolutely. And I do want to take a moment to thank GuideForce for hosting these sessions. To learn more about GuideForce, head on over to guideforce.com. And we'll see you next time on the Startup Leader Show.